So I'm going to start term 2, part 3 of what we teach. So I'll start with the simple programs of using do while and while. Then I will go to the more complex ones. So let me start with an example. Let me code something, then we shall run and see what happens. So as usual, I'll open a new page. Then I'll start this. Hash include as usual. I'll use int main. Open braces. I will introduce a variable. I'll call this variable j, and I'll give it a value of 0 at the beginning. Int j equals to 0, and then I'll do something like this. I'll start with the do. I want to print. I want to print this message. The value of j is equal to that, and I'll do the declare calling. It can then this can call the j, then do the adding of j as a loop. In that loop, that's what I want. Then every time j appears, I would want a new line. So I'll put that. That's a simple program of displaying numbers. So this is do display this sentence, and the j which started as 0 will do an increment of 1. That's why we have this, an increment of 1. And as it is doing that, I can put this condition that j doesn't go beyond the 3, and then close the program. I started with int main, so I'll again close with return 0. We'll have a look at what will happen. After that, I save. Let's see what happens. I save the code, then we'll compile and run it. Then we shall be able to see what will happen. After saving, I compile. If there's no error, I run. You see what is happening? So j starts at 0. So this sentence is what you are seeing here. It starts at 0, and because of this increment, at every time there is a loop, it's adding 1 until the condition is while j is equals to 3. That's when it stops. So it starts from 0, adds until it gets to 3. That's one example. I can do another example of now I can use while. I can now use while. Let's start another example of while, of something almost similar to that one. So I'll start with as usual, hash include, simple programs for start. I'll again use this. Then I can do that. I can start with a variable called count. Count can also start at 1. Let me start at 1 this time around. Then use while count is lower or equal to 4. Let it not go beyond 4. What should it be doing? Let me open the brace. While count is lower or equal to 4, let's have a message saying, like the other one, but this can be maybe shorter. Can have that. Let me use this. Can put some space there. You'll see what will happen. I'm calling count, and again I would want an increment. That way, in that loop. That's how I want the count to start at 1, count 3. While count is lower than 4, let it do an increment until it gets to 4, and then close the program here. Let's save this, then see what will happen. This I'm using a while example 1. After that I compile. It's no error, so I can now run and see what will happen. This is displaying 1, 2, 3, 4, 5. In case you want them vertically, or in case you'd want a sentence, you can simply write it here. If you want line each to occupy its own line, you can have that. If you want this same message, the value of j is equals to, I can say the value of I can put it there, the value of count is equal to, it can be similar, but the difference is one is do while, the other one is while. After that change, I compile. After compiling, I run. Going to display them 1, 2, 3, 4. So they're almost doing the same thing, but this one is do while. So action followed by condition. Action, do, followed by a condition. This other one is condition followed by an action. So here they can be adjusted to be the same. If you put this to be 3 and compile, then run, they will appear the same. They will be doing the same, but the coding, one example I have used do while, do this action when the condition is this, and then this other one starts with the condition followed by an action. So let's also do another example of another simple example. You can open a new program, again hash include, I'll do an example of the same. I can use int main even now. I can start with braces, then introduce a variable called int, a variable a that starts at 10. Simple program. I can use do what? Do the printing, the displaying of value of a as equal to that. Can start a new line and then call the a to do an increment. This is another way of doing an increment. A shall be +1, then that loop ends, and then I put a condition while a remains lower than 20. While a remains lower than 20. So this program, it starts here. A starts at 10. This is the message I would want the computer to display. Value of a, do an increment of 1 until when a to the point that a always remains lower than 20. Let's save. Then we compile. Then we run. See, a starts at 10. Why? Because here I've initialized it at 10. It's declared as an integer that is defined to start at a. Then it does the adding of 1. This adding of 1 is as a result of this line in the loop. So there is a loop doing this several times until the loop stops when you get to 20. So when it is lower than 20, it stops. It can't go display 20 here because here we've put less than 20. If you had said equal to 20, then it would have stopped at 20. But because we've said lower than 20, then the last point is displaying 19. That's a very simple program. I believe when you also practice with these examples, you shall be able to differentiate the difference between do while and while. Let's do the last very simple example. Then we now can do something a bit more complex. Another example. Let me use 4 like I have been using with the previous tutorial. Let A start at 10 with 4. 8 start at 10, condition 8 remain lower than 20, just a way of showing you and as a recap. And then A to can even use this, that can also work. For 8 to start at 10, A to remain lower than 20, and A to do an increment of 1. It's a style you can also practice. Slightly different from what we've been doing in topic in part 2 of term 2 work. Is the message. I call the A. This ends here. When I can now close the program here. Let's see what this will do. Save. It's a 4. Let's compile. Let's see what happens. It's again doing the same thing, but this is a case of using 4. So what has happened, the running is the same as this one, only that here I've used the for loop. 4 starts at 10. This is the initializing figure, condition, and the increment. You can write the increment this way, or as I have been writing in my previous tutorial of term 2 part 2 work. You can also have a look at what I've been doing with it in the previous video. So let's any change you do, you compile and you run. You will be able to see that what will happen. So the output is the same. You actually can't tell the difference whether I used this or this. When they are on run mode, the output is the same. Those are good examples that can assist you in coding. You can practice this. By the time you get the last one, you will be very good. Let me now do something a bit complex a little bit. So I'll do a program of a case where it's a program that will sum up all the even numbers between 2 and 100. A program that shall sum up all the even numbers between 2 and 100. I believe when I do the even numbers, as you practice, you can also do the same for odd, and you'll be able to practice and learn a lot by yourself. So let's start a new page. I'll start as usual. I want to sum up all even numbers between 2 and 100. So as usual, I'll open the program. I'll use int main. So I shall remember to close with return 0 at the end. Then I'll open braces. Then I'll put my first variable is num. That shall start from 2. If it's odd numbers, you'll start from 1. If it's even numbers, I'll start from 2. Then another variable I'll work with is sum. Sum because I'll be doing summation, I'll start at 0, so sum shall be 0 at the beginning. After that, I request for the data. The even numbers from 2 to 100. That's what we want to do. This is just the output display message. I can start a line so that the values can start from there, from below this sentence. I'll use while num shall remain lower or equal to 100. Since we have to get to 100, what will happen? I open the loop. I want these figures displayed. These figures displayed one after another. I can now call the num. So what will happen? Num will start at 2, sum is at 0. These figures will start generating and they won't go beyond 100. And what will be happening? The sum shall be doing an increment of any other figure you put under num. Any other figure you put under num, it is captured and added to the sum. So for every loop, sum having started at 0 will be adding to any figure you type, any figure to any figure that is generated by the system. So as long as it's an even number, it's going to be captured. Not typed. These ones are automatically generated by the system. So that's the looping. The looping ends there. So what will happen? Num will start at 2, sum is at 0. This sentence will appear, and then it's going to generate the figures. The loop will stop here. So what's going to happen? Sum has started as 2, as I have said. Sum is started at 0, num is at 2. This sentence will appear. Then these figures will be generated from 2. And it's going to be adding 2. As it is adding these 2, it is picking the sum here, which started at 0, and adding to the num that is generated by the system. So as it is adding them, at the end it's going to display this sentence. We shall run and see what will happen. After that, I save. If there's any error, we are going to correct it. So 2, 0, 2 plus, because of this, 2 plus 4 plus 6 plus 8 plus 10, that way. Let's run and see. So they are so close to each other, so we first want to display them. This is for displaying them. After displaying them, let's put a space here. There's some space. and then we are calling this num, printf as that. This is the figure. This is adding num2 plus num, so you can put some space here. Let's compile and see what will happen. Sum of the even numbers, so the figures are having some spacing. So let's work on the summation here. We need to call that sum. So here we shall call that sum, so that it doesn't just show us the last num, but it also shows us the last sum. Compile, then get to see what happens when you run. So I want this one to have some space, then we now can have the sum. These are all the figures from what? From 2 to 100. I want this to start a new line, this sum to be somewhere down here. So I shall put a /n here. You can even put 2. Then compile. You compile to capture any change. So this is the gap I have put. So the even numbers are as follows: 2, 4, 6, that way. After displaying all this is as a result of this 2, then 2 here is generated as the first one. Sum is at 0. The last point is 100, which is this one, and then sum shall be adding any number that is generated as a result of adding. That's why we are putting sum plus equals to num. So num is the figure that is generated by the system, so it captures that figure, adds to the 2. So it's simply adding 2 plus 4 plus 6 plus 8 plus that, as the loop continues until when they get to 100. So once they get to 100, it then now gives you the answer. After they get to 100, that's when this message comes. The loop ends. After the loop ends, this message comes. That's what we mean. After this message comes, we call the sum. So the sum, the last value you get at the sum after the loop ends, is what is displayed here. So if you add 2 plus 4 plus 6 plus 2, all these figures, if you do a summation of them, the total figure will be 2,550. That's what we simply mean. You can practice using this example. You can practice with odd, where here you start with 1. Here you still be adding 2, and you will call this sum, and then this will now be even numbers. It will work. And even when you do with the calculator, it's going to be correct. That's a good example that can help you in practicing. I also can do one other example for practicing, where let's open a new program. Can do another simple program where we write a program that uses the function square to print squares of even numbers, printing squares of even numbers between 1 and 20. So to print squares of even numbers, we will again use let's also practice with that one. I believe these examples shall assist you in practicing and learning. So we want to do, I can introduce I'll use what? I'll use I'll use another style which you also can practice, where you can use that. Square is something known. where we want to use that at the end. I want to code with another style. There are so many ways of coding, but this one is also applicable. You can use the old style, or even this one where you are calling num, num times num. I want to use a figure called num. So it's a style of coding where you will call that num. Then we do now start the program. Int main, as you're used to. Then we open braces, then request for data. We want the data to be automatically generated, so these are squares. I want this sentence. These are squares of even numbers between 1 and 20. Let me use 4. Squares of numbers between 1 and 20, so the figure to start with is 2. Condition I will introduce I here. For I is equals to I to remain lower than or equal to 20. I to do that automatic addition of 2 as it is displaying the figures. That's my loop. So what should the loop do? The loop should be printing these figures. A new line. I want to call the I and also call the square. The square is up there. You will see what will happen. Then we close. So print if the squared is equals to this. So the square up here is I will show you what will happen. So what is happening? So square has been declared up here, which is a case of num times num. That number you type times itself. That number you type times itself. So and then the num is for I to start at 2, I to remain or equal to remain lower than 20, or the last point being 20. I to do an increment of 2. Let's save. Let's compile. If there's any error, we are going to rectify. So here there is something missing, a semicolon, something missing here. Let's see what is happening. int is equals to square, which is int num, return equals to num times that. The program starts here. Value is what? Square of the even numbers. For I is equals to 2, I to remain lower than 20, I to do the plus and equal to that, when the square is equals to that. Here we are calling, there's something missing here, something missing here. So here this is supposed to be here. Then we call I. Run. Is dot. So the square of 2, this 2 is 2, 4, 6 up to 20. Here it's generating the total. So if you check here what is happening, it starts at 2, remains lower than 20, and does an increment of 2 at every loop. As it is doing that, it is displaying this figure. So this sentence is, you can even put a there here, the number that let's compile and see. You can rephrase this sentence. The number 2 is what when squared. You can adjust the number that is, it's just the arrangement is that when squared. You can rephrase the way you want. So this first shall call this one, and this second one shall call this, which happens to be that number by itself. The number 2 is 4 when squared. The number 4 is 16 when squared. So you can rearrange the way you want. Even you can put this at the beginning. Each time you make a change, you compile, then you run. Whichever way you want to arrange them. This is simply putting a space. If you don't want the space, you can put that. That's the output. So you can rephrase this sentence the way you want, as long as you are, in case you want to display all of them here, you will know how to call them. You even can start with the square here. And put the I at the end. So when you do that, you will have to rephrase this. the square is that to the number that you can rephrase this. So this first one shall call it the one that is starting here, and this second one shall call this one. So if you compile, if there are errors it will show us, if there are no errors it will be quiet. Then if you run, the square is 4 to the number 2, so we have simply interchanged. The square is 16 to the number 4, the square is 400 to the number 20. So it's able to play around with the display. So you're able to play around with the display to what you want. Let me do the last example, and I believe that if you go through these examples you will be at a very good position to even practice others. The C programming is very wide, so we simply use examples to try and see that we are capturing everything that we can. So let me do a program that requests for any 10 numbers in an array. These numbers are then displayed in reverse, so it will request for 10 numbers. Once you feed these 10 numbers, it will then do the displaying of these numbers in reverse. So I can copy this because of time, then open braces. I'll work with a variable called I. I also work, if you're working with number arrays, you can use that. The array works with 10. You can review this channel for more about arrays in the previous videos. I will use for I to begin at 0, I to remain lower than 10, I to do an increment to every loop. So this can be here. I want to then request for data. Let me request for that data. Request, this is a case of entering data. Enter the 10 numbers. Enter the 10 numbers. After that we do the 4. After the 4 we open the loop. After we open the loop, what do we want to do to this scenario? We want the looping to be bringing a sentence that says a sentence on the screen that says enter the number what, number 2, number what, that way. Number what, as it is displaying that, it's able to also guide you in knowing which number you are at. So for that to happen, so as you are feeding the first number it shows you 1, as you are feeding the second number it shows you 2, as you are feeding the third number it shows you 3. So that's the style I want to use. So I'll open another bracket here and make that I be added by 1 for every sentence that is displayed. I'll show you what will happen. So as it is doing that, as it is displaying every number and you enter, it can be capturing that number and be storing it in its memory as an integer type, that is of an address and a location, address of its number, and the numbers are of array kind, and as it is capturing that, it captures it with the consideration of I, so that the I can be up to 10. That's what the loop is going to be doing. So as it is doing that until it gets to 10, so you will feed the numbers one after another until you get to 10, because this is I here and I has a condition of 10. After that, it can now display these figures. Let it display these figures. The numbers in reverse. I want them displayed in reverse. We shall see what will happen. And after this sentence comes, I would want to start a new line. So because we are going in reverse, so we shall play around with this. But now in reverse, shall play around with this by making a few adjustments. So as it is displaying these figures, let it start at 9. Display them up to the point it's now the opposite, up to where it is above or equal to 0, and this is now the opposite. You can put here 10 and here start at 1. If here you started at 1, you can put equal to 10, so that will depend with how you are also coding. So if I put here 9, then this will be above 0. So what do I want to do? I want to display those numbers one after another in this loop. This is a loop I'm opening for that for condition where it starts at 9. So I want the display of these numbers. These numbers are to be displayed, and these numbers are of array kind. They are of array kind. They are of array kind. That way, then I close the program. If there is any error, it's going to show me. So let's start from the top. The program starts here. The number, this is the variables. One is a normal integer, the other one is array kind. Enter the 10 numbers of your choice. Any number of your choice. Then this is the condition. So it starts at 0. It will be requesting the numbers as it is bringing this sentence. This sentence will repeat itself until you get to 10. After that, it will capture and read to every number you will have entered. The loop will end. Then this sentence will come. After this sentence, it's going to now rearrange these numbers one after another. Let them be arranged in each occupying its own line. So I'm putting that. Then we compile. Let's save. Give a name. This is a numbers in reverse. For loop 10 numbers in reverse. I always save as per also what the program is doing for remembrance. After that, I compile. If there's any error, it's going to show me. For I is equals to, there's a mistake here, there is a semicolon. Then compile again. is a semicolon. Compile again. Each time there's an error, it's going to show me. After that, I run. Enter 10 numbers of your choice. I want this to start a new line. So I want this to be down here. So let me put a /n after the choice. After the name choice, let's have that. Compile. Then we run. So that, let me also put some space here. Enter the number of your choice. Let me put some space there. Then compile. After that, I run. So there is some gap here. Any numbers of my choice: 6, 8, 9, 2, 4. Which one? 5, 11, 12, 13, 15, any number. So it's going to display these numbers in reverse. I started with 6 comes down, followed by 8, then 9, then 2, then 4, that way up to the last. How is that possible? So when you follow this code, enter the 10 numbers of your choice. This is the sentence. A new line starts. For I is equals to 10, so this will be 4, then this loop starts. So this loop is for enter number. This will repeat itself, as I was saying, repeat itself until you get to fill 10 figures. So after you fill 10 figures, it will stop, the loop will stop. That's what you are now seeing here. I enter the first as 6, the second as 8, the third as 9, up to the last one as 15. That loop ends. Then this sentence comes. This sentence is now this one. After this sentence comes another loop, but now it's the opposite of this one. So for I to start at 9, if I start at 9, it now means here I will be remain above 0 or 0 itself. So the array value of 0 shall be the first one to be displayed. So I shall start at 9. So the last one you entered here is 15. That's what you are seeing here, followed by 13, followed by 12, followed by 11, 13. So it starts at 9. So because 9 is your last one, here we are starting at 9, here we're starting at 0. If you put here 10, then here you will remove the what? The equal sign, so that it can start at 0, so that it's now the same as this. So it will remain this, then the condition is deducting, so it goes in reverse of this, in reverse. That's why you are now seeing they are in reverse up to the last one. Those are some of the examples. If you practice these programs, I've done 1, 2, 3, 4, 5, 6, 7. These 7 programs should guide you in practicing, and also be visiting this channel. You'll be getting more. Yeah, that's all, and all the best from me in programming, all the best from me in programming.